Hello. So this video is on the psychological theories of someone named Heinz Werner, who is an important developmental psychologist, although these days his theory has been sadly forgotten. But I think Werner offers a really interesting view of the mind and of development, although I'm admittedly biased. My doctoral advisor, Joseph Glick, was actually Werner's student. So I have a maybe deeper understanding of Werner than I otherwise would have. But as I said, I think he offers a really compelling and interesting way to think about the mind that's very different from a lot of what's otherwise available in psychology, and is, I think, a lot more lively and true to our experience in certain ways. So, to begin with looking at Werner's ideas, I want to start with one of his central Werner's definition of development is known as the orthogenetic principle, which is stated here. He writes that whenever development occurs, it proceeds from a state of a relative lack of differentiation to a state of increasing differentiation and hierarchic integration. So, in other words, to put it simply, when something develops, in any case, at least in psychology, and this would be true in biology as well, I think, there is an increase in differentiation and an increase in hierarchic integration. So I want to look at what Werner means by these two things. So the definitions of them here, but it's easiest to explain them with examples. So the first, and I think one of the most accessible examples, is with the development of the embryo. So this is after conception, shortly after conception, when the fertilized egg cell, the zygote, begins to change. So what we can see here in this image is an illustration of the stages of embryonic development, starting with day 1, then day 2. So focusing first on the first 3 days, what you see is that the initial zygote on day 1, on day 2 has split, and split again, and split again. So you have, whereas you originally had one single cell, you now have multiple cells. But each of these cells is more or less like all of the others. In other words, they are not differentiated. Obviously, at some level, each cell is slightly unique, and there has to be some difference. But by and large, each of them is like the others. And that's shown well here in this diagram. Each is just a yellow blob with a black dot in the middle. But as we go on, what you can see is that eventually the cells are not just splitting, but they are becoming different. They're differentiating. Whereas they're initially just yellow cells, as this diagram shows, eventually some of them differentiate and become orange colored. And then later you can see that there's further differentiation. There's now a third type, the pink cells. And obviously this goes on, and you see more and more differentiation. And obviously at the point when you get to birth and thereafter, we know that our bodies have many different parts. We have bone cells, blood cells, skin cells, retinal neuron cells in our eye. the mature human being, or even a newborn, is highly differentiated. But this is the outcome of a developmental process that started with a very undifferentiated embryo. Now, I've shown differentiation at the embryonic level, but remember, according to Werner, development is not just differentiation, but also hierarchic integration. It's increasing differentiation and also hierarchic integration. So with the embryo, we can see this in terms of the fact that the different parts of the embryo don't just remain randomly different. They don't. In other words, the cells don't differentiate into randomly different types of cells. The types of cells that make up our body have functions that complement one another. Some functions are overseeing other types of lower functions. We're not just a random assemblage of different functions that don't work. When that happens, our body ceases to live. So this is now hierarchic integration. The fact that the differentiated parts of the organism are not just randomly differentiated, but differentiated in a way where their functions integrate. So let's turn now to another example of the orthogenetic principle. As I mentioned, Werner's goal is to describe what development is in general. So not just on a biological level, like the embryo, but also in the case of language development. According to Werner, the developmental changes would also reflect the orthogenetic principle. So we can see this here. Consider very young children or infants learning their first words. When infants first learn words, first of all, they don't learn many words. They start with just a couple of words, and they use them very broadly. They might apply them to many different types of things more broadly than an adult typically would. So, for example, an infant might learn the words, or would inevitably learn the words mommy and daddy, but they wouldn't just use these to refer to their mother and father. They would use them to refer to all different sorts of things. So, for example, an infant might refer to, seeing different trees, referring to the mommy tree and the daddy tree. So they're not differentiating between the specific people who are their mother and their father and other objects. The term is just applied very broadly. As they develop, though, they learn other words, and the functions of the words become more differentiated. They apply them more narrowly in specific differentiated ways. Another example of this is also with word learning. Is imagine like a toddler learns the word dog. First, they might over-apply the word dog. They might describe any four-legged animal they see as a dog. What this indicates is that they haven't differentiated the concept yet, or differentiated the meaning of dog from other types of things. They're using it to refer to all sorts of animals. But as they develop, they narrow down that meaning. Now, you can also see here the role of hierarchic integration. Children are learning words for animals. They don't just learn that the words have different meanings. The words' meanings are hierarchically organized. So whereas a toddler who knows the words dog and animal on some level will fail to distinguish them in certain ways. They'll say, dogs are animals, but also all animals are dogs, which is not true. Only later do we realize, or can the child come to articulate, that only some animals are dogs. All dogs are animals. A dog is a type of animal. So you can see in this hierarchical chart here, the bottom left quadrant of the slide. Dog is a member of the category animal, as is cat. So all dogs are animals, all cats are animals. Some animals are dogs. but not all of them. If you talk to a toddler, young preschooler, they might be able to use these words, animal, dog, cat, but they will often, earlier on, when their thinking is less developed, when their language is less developed, they will not distinguish the terms in a way that shows any kind of hierarchic integration. Another example of the orthogenetic principle, where we can see how children, as they develop, go from a less differentiated, less hierarchically integrated way of functioning to a more developed way of functioning, is with drawings. If you observe the way that young children draw and approach the activity of drawing, one of the things that you notice is that young preschoolers, for example, will not be able to decide to draw something and reliably follow through on their initial plan. So, for example, the child might decide to draw a tree, but once they start drawing, the drawing might look like something else to them, and now they're drawing that new thing. Werner would say that the child is not distinguishing or differentiating their goal from their progress, relating those to each other. You can also see this with this drawing here of the sun and the person, if that's what we want to call that. I don't know what led the child to draw this person in this way, but one explanation that would illustrate the orthogenetic principle would be that the child set out to draw a person. They began maybe drawing a circle, but once they'd drawn a circle, they put the legs directly onto that, as if it were the face, failing to differentiate between their progress so far and the overall goal of drawing a person. So although maybe this child is more able to differentiate the goal from the progress, but still not perfectly, so that the legs are attached directly to the person. All right. So finally, another example of the orthogenetic principle, or another general aspect of Werner's thinking, is that, or another way we can see how at an earlier point in development there's less differentiation, less hierarchic integration, and that as development occurs we see increasing differentiation, is with psychological processes themselves. So psychologists will commonly distinguish between different psychological functions like memory, perception, action. And in studying children today, the common approach is to specialize. So psychologists might study memory in infants or language in preschool age children, things of that nature, motor development. Now, for Werner, this approach doesn't make any sense, because for Werner, these separate psychological functions, or these functions that we identify as separate as adults, are in children's mentality fused. They are not differentiated. Now, this doesn't mean that the child's eyes are fused with the areas of their brain involved with memory. Obviously, Werner's aware of that. What Werner's point is that the separation between psychological functions like memory, perception, and action, which makes sense to adults, does not validly apply to children's thinking. Children's thinking is not differentiated along these lines, according to Werner. So let me give you an example of this from the Crane textbook. So imagine you're presented with this thing here, this blue triangle, and asked just to report, to describe, as if you're in a psychology experiment, to describe literally what you see. Describe objectively what you see in this literal way as possible. So as adults, we might say it's a blue triangle, or the outline of a triangle in blue, approximately equilateral. Now, if you presented the same task to a child, according to Werner, would likely say things like, they would, at least in our context in the United States, they would likely say it's a triangle, because their children are commonly taught shapes. But they wouldn't just stick to what it looks like. They would say things like, it looks sharp, it's used for digging. Now, what's going on here? Why is the child saying the triangle looks sharp, or that describing it as looking sharp, that's used for digging, that it would hurt to touch the edge of it? In Werner's mind, what this reflects is the fact that the child cannot distinguish between what they're literally perceiving, the visual perception. They're not distinguishing between that and the actions that what they're seeing reminds them of, their memories of interacting with things that were that shape, that maybe led to particular experiences, like being, having their finger pricked by the sharp edge of something. Now, we can make these associations as adults, just like children can. The difference is, and this is something that we'll come back to and that Werner comes back to, the difference is that children only think this way. Children are not able to think in other ways. So when we hear a child say the triangle looks sharp, even though it's not literally sharp, we know what they mean. We're still able to think in that way. But we're also able to differentiate out the purely perceptual aspects of our experience, the visual perceptual aspects, from other aspects. We can see how you could say that the triangle is used for digging, that it's sharp, but we can also recognize that it's not literally sharp. That is a quality of a different type of object. Here's another example of the fusion of psychological processes in children's thinking. In a study done that was informed by Werner's perspective, a psychologist interviewed children about their trips home from school. But one child every day walked home from school. They had a long walk, and along the way they would habitually stop and take a rest under a tree. So the psychologist asked the child, "Tell me about this place where you stop and where you take a rest." The child said, "There's a tree there. The tree is by a house. There are people who live in the house." When the child was asked to describe these things, they didn't describe the objective elements of the situation. Like it's an oak tree, that the house is white, the family has such and such number of people in it. Instead, their description of the tree and the house and the whole place was completely colored by the child's own particular history and memories in that situation. So the tree was the resting tree. The house was where the resting people lived. What were the resting people like? They were relaxed. They were taking it easy. Were they doing things all the time? No, they were resting. But none of that was actually true. That was the child's experience in the situation where they were resting. But what Werner would note here is that in the child's thinking, there's no differentiation between their particular experiences, resting, and their perception, understanding of the situation that they're in. It's only as adults that are thinking, or only as we develop later childhood and into adulthood, that we develop the ability to differentiate out our own particular experiences, our own personal meanings in certain situations from the objective characteristics of those situations. One way to describe this process of differentiation, the forms of thinking involved before and after, is that children's thinking is characterized by what Werner labels physiognomic perception. So physiognomic perception describes the way of thinking where qualities of living things are attributed or perceived in non-living things. So, for example, a child seeing the number 5 here, a child might say that asked about what does the 5 look like, rather than, as an adult might say, that it's written in white, there's a blue background. A child might, in addition to saying that, might say things like the 5 is angry, it looks menacing. This is physiognomic perception. As adults, we are able to recognize that the 5 is not literally menacing or literally angry. It's a category error. It's the written numerals are not things that can be angry or menacing. But for children in their physiognomic thinking, this can be the case. But again, as I mentioned before, although we can, as adults, recognize that 5s can't be angry, we can also still understand how children would see things this way. And we can see things in this way ourselves, maybe not the exact, particular ways that children do, but we can still, as adults, not just remember how we once saw things this way, but we can still see them this way. And we can learn to cultivate our ability, we can develop our ability, actually, to see things, to perceive things physiognomically. The typical developmental change from childhood to adulthood regarding physiognomic perception is that we learn to distinguish what is living, what is not living. So an example of physiognomic perception. Consider these lines here. You're asked to describe the line on the left. Think about the words that you would use. I've done this with students, and students will reliably, at least after a few responses, someone will inevitably say something like, the line is curving up to the right. But curving implies movement. But the whole line isn't moving. The whole line is there at the same time. It was just imprinted directly on the screen. There's no curving, but we can perceive the line this way, just as we can perceive the one on the right side as sort of slumping down to the right. Again, this is not a quality that is literally or objectively in the line, but it is a physiognomic quality that we can still as adults perceive. I would bet if I asked people which line is happier, there would also be very consistent responses. Despite the fact that in a literal, objective, intellectualist or rationalist way, neither line is happier. Happiness is a quality of living beings, not of drawn lines. Now, this way of thinking is obviously important, but if we take it as our only way of thinking, we're overlooking something important and very universal about how our mind works. And this ultimately is Werner's take-home message, that despite his theory claiming that development involves our thinking becoming more differentiated, that we learn to perceive things in terms of distinguishable qualities, this is not ultimately the way that our mind at a fundamental level works. At a fundamental level, we can easily and immediately grasp the line on the left as curving up to the right as a happier line. We can readily understand how a written numeral could seem menacing. What develops is the ability to grasp that this is literally not, in some sense, the case. But if we forget this, in Werner's view, we're overlooking the fundamental way that the mind works.